Hello folks, so in this video I want to talk about how we can solve systems of equations with another method, and this one's called elimination. And so let's build a system right here. So let's suppose the system I want to solve is something like this. 3y plus 2x equals, I'll say 12. And my second equation is going to be, so I'll number that one equation 1. Equation 2 here will be, let's say, negative 3y plus 7x equals negative 3. Pretend. Okay, so what I'm going to do here is, well, we should put on one observation. You can use the substitution method that we've been doing. The problem with that is that this one does not really lend itself to that very well. Here's what I mean. If I was to rewrite, let's say, equation 1, and let's suppose I want to solve it for y. Well, I would have to say, let's see, I'll move the 2x to the right side by subtracting it. So I'll have negative 2x plus 12. And when I divide by 3, I have to, again, to the entire left and right side. So I'll end up with, oops, sorry, make sure you can see that. And I'll end up with y equals negative 2/3 x plus 4. And that's fine. But now what would I have to do is, well, I would have to take that y and substitute it in. And you can see it's going to be pretty messy as is, or it definitely could be. And so I don't really want to deal with that. Now, if you did do that, that would totally work, and as long as you did it carefully, there's nothing wrong with it. But again, I just want to show you another way which might be a little bit cleaner. And here's what I'm going to do. I'm going to start off with equation 1 here, so I'm just going to copy it over here. Zoom out a little bit. So equation 1, not changing it at all. 3y plus 2x equals 12. And I'm going to do something maybe a little bit crazy here. And I'm going to add in to both sides, the left side and the right side, a negative 3x, and there's a reason I'm saying plus negative 3, by the way. Not 3x, just negative 3. And that's totally fine, right? So I could just, there's no reason I couldn't take an equation where the sides are already equal and add negative 3 to one side and negative 3 to the other side. Right? Nothing wrong with that. But remember, I already know what negative 3 is actually equal to. If we look over here, we know that negative 3 is also equal to negative 3y plus 7x. Okay, why is that relevant? Well, let me actually underline that. The reason that's helpful is because I can do a little substituting, in a sense, into this equation. And so what it's actually going to be different now is I'm going to write it like this. 3y plus 2x equals 12. On the, oh sorry, that's a plus right there. On the right side, I'm going to add in negative 3. Same thing, so also known as subtracting 3. But on the left side, I'm going to add in negative 3y plus 7x. Again, why is this okay? Well, remember that this right here, this is negative 3 according to this equation, number 2. And so really what I'm doing is I'm just adding negative 3 to both sides. And remember, because number 2 is an equation, it says negative 3 and this quantity, negative 3y plus 7x, they're exactly the same. So they're interchangeable. Okay, why is that helpful? Well, when I add them down, right, so we just add them straight down. On the right side, I'm going to get 13 minus 3, and I'll get 10. On the left side, well, I'm going to get 3y plus negative 3y, so that's going to be 0y. So I'll say 0y. And then 2 plus 7 would be 9x. Like so. And now we can see, all I have to do to find x is just divide both sides by 9. And I'll get x is equal to 1 over 9. Oh, sorry, 10 over 9. And just like before, once I have the first one, I just need to plug it into one of the other equations to get now y. So I will do that. Let's plug into no rhyme or reason. As to, again, as usual, you would want to pick the easier one, but I don't think anyone is obviously easier, so I'll just plug it into equation 1 here. I'll get 3y plus 2 times 10 over 9 is equal to 12. So that's going to be 3y plus 20 over 9 equals 12. I didn't make a very easy example here, but that's okay. I'm going to get 3y is equal to 12 minus 20 over 9. So I just subtracted 20 over 9 from both sides. Let's see, I'm going to have to change 12 by writing 12 times 9 over 9 to get that common denominator. So I'll get 3y is equal to, I think 12 times 9 is 108 over 9, which will be, let's see, what would that be? 88 over 9. And last part here, I'll divide everything by 3. Oops. It's a little hard to see here, but instead I'm actually going to multiply by 1 over 3. Like so. Times 1 over 3. And we will end up with y is equal to 88 over 27. And I don't think that simplifies at all. So that's our final answer to our system. Now, this is why it's called elimination. Is that when we combine the equations by adding them straight down, we simply got rid of the y's. The resulting equation was 0y, is y has been eliminated. So that's why it's called elimination right here. Right? But hopefully that helps, and now you don't have to deal with all those messy fractions if you were to use substitution. Ready? So thanks for watching. I'll see you in the next video.